Hello everybody, let us now discuss the average acceleration. Okay, so how do we define the average acceleration? It is defined as the change of velocity divided by the time interval during which that change occurs. So mathematically it is given by this: average acceleration is equal to change in velocity, that means v2 minus v1, divided by t2 minus t1. Okay, and instantaneous acceleration, what is it? It is equal to the average acceleration taken over an infinitesimally small time interval. So just like before, when we discussed the instantaneous velocity, we use this term taken over an infinitesimally small time interval. And this one, how do we write this mathematically? We write it by introducing the limit. Okay, so this particular part of the limit, it says limit here delta t tending to 0, which means that the time interval is infinitesimally small. Okay, so if you take the limit of this, what is this? This is the average acceleration, delta v by delta t. So if you take the limit delta t tending to 0 of the average acceleration, you will get what? The instantaneous acceleration. And this is by definition is equal to dv dt. That means it is the rate of change of velocity. So you can reframe the definition of instantaneous acceleration as the rate of change of velocity. Okay, let us do some numerical problems. Some examples. For example, let's say we have a similar kind of an example. The position of a body is given by x is equal to, let's say, t square plus 3t and minus 2. Okay, where x is in meters and t in seconds. You're going to get these kind of problems, a lot of them, in the exam and even in the in your tests, so on. Okay, so here calculate the number one, acceleration between 2 seconds and 3 seconds and number two, the acceleration after 10 seconds. Okay, so let me just do one thing. Let me give the power here to be 3. Okay, and let this power here be 2. All right, so here, how do we do this? So the first part of the question, it asks about the acceleration between 2 seconds and 3 seconds. So that means in this interval of time, what is the acceleration? So that kind of acceleration where you are taking between intervals of time, that is the average acceleration. And here they ask you to calculate the acceleration after 10 seconds. So that means exactly after 10 seconds. So what kind of acceleration is this? It is the instantaneous acceleration. Okay, so let us do the first part here. Okay, right. So what do we do out here? Let's do one thing. We know that v1 first of all. So what is v1? V1 here is the velocity at the time t1, and v2 here is the velocity at the time t2. But in this question they have given you the position, not the velocity. So what we can do here, we can first differentiate this with respect to time to find the velocity, to find the expression for velocity. After that, we will substitute the times. T1 we will get v1, and if we substitute t2 we will get v2. So here we already have x is equal to t cube plus 3t square minus 2. So therefore, what will be velocity? Differentiate this. So if you differentiate this, you get d dt of of x, which is t cubed plus 3t square minus 2. If you differentiate this, you will get 3t square plus 2 and 2 3 is a 60 minus 0, because if you differentiate this 2, that will be 0 because it is a constant. Yes or no? T1, we will get here V1. Mm, 3t square plus 6t. 3t square plus 6t. And what is t1? T1 here is 2 seconds, if I'm not mistaken. And t2 here is how much? What is the value of t2? 3 seconds. Okay, 3 seconds. So therefore, what is v1? V1, you substitute instead of t, right, the value of t1. So this will be 2 square plus 6 into 2. Okay, so here this will be 4. 2 square is 4. 4 into 3 is 12. 12 plus 6 into 2 is 12. That will be 24 meter per second. Okay, what about v2? V2, this is 3. Then t2 is, so this will be 3 square plus 6 times of 3. So much is this? 3 square is 9. 9 3s are 27. Plus 6 3s are 18. So we have 14, 15 here. 2, 3, 4. 45 meter per second. Let me check. So 14, 15, 5, then 2, 3, 4. Okay. So therefore, average acceleration, let's put back in this formula that we have written in this formula here. So you have v2. V2 here is 45 minus v1, which is 24 by t2. T2 here is 3 minus t1, which is 2. So that will be 1. So that will be 2 divided by 1. So this is 21 meter per second square, because it is the acceleration. So it should have meter per second square. Okay, so that is the first part. Now the second part, you have to find the instantaneous acceleration. Okay, so how do we find the instantaneous acceleration? We know that instantaneous acceleration is defined as dv dt. So dv dt, we already found the value of v, the expression for v, and this is the expression for v. So you have 3t square plus 6t. Okay, so if you differentiate this, you will get 6t plus 6, right? So therefore, after t is equal to 10 seconds, so a will be how much? 6 into 10 plus 6, that will be 66 meter per second square. That is the answer. Okay. Position of a body is given by, let's say here, the 4t square plus 3. Okay, where x is in meters, and after 20 seconds. First of all, we have to find the velocity, just like before, isn't it? So we find the velocity by differentiating. d dt differentiation of 3 will be 0. Let us not write this 0 0. Yeah, okay. All right, so here you get this much. All right, so therefore what is v1? V1 you get 8 into t1 here is 2 seconds, so 8 into 2, which is 16 meter per second. What about v2? V2 will be 8 into 8. 8 is 64 meter per second. So average acceleration will be v2 minus v1 by t2 minus t1. So v2 here is 64 minus v1, which is 16, divided by t2. T2 is 8 minus 2. So how much is this average acceleration? Let's see. 64 minus 16, so that is 48. 48 divided by 6, divided by 6, you get 8 meter per second square. Let me check. Velocity, okay, dx dt. All right, 4 to the 8, 80, correct. So v1 you substitute. Okay, so there you go. Now right, acceleration, okay, average is this much. All right, so now let us find the instantaneous, the second part. So how do we find the instantaneous? We differentiate the velocity, is it not? So that means we differentiate this 60 or 80, let me check. 80. Which part? We differentiate this because this is the velocity, right? Velocity is equal to 80. So differentiating this, okay, so if you differentiate this, you will get 8. You will get 8. Okay, and you can see here that now the acceleration is just 8. It is independent of time. Okay, independent of time. You don't have the time anymore here. So that means whatever time you put, it will always be 8, independent of time. So such an acceleration which is independent of time, that is a uniform acceleration. Okay, so here you can see that the acceleration is uniform, right? It'll be 8 meter per second square. Got it? And why is it uniform? Because it is independent of time. Okay, let me just check here once again. I think something I feel like I have a gut feeling that this is wrong. Okay, x is equal to 4t squared plus 3. Our x is in meters, t is in seconds, so acceleration between 2 and 8 seconds. So we first find velocity by differentiating x. So you differentiate this, you'll get 80. Okay, then we put v1 by putting the time, 2 seconds here. Seconds, correct. Okay, now if you find the instantaneous, it comes out to be 8 meter per second square. It is independent of time. Okay, so that means that this body is going at a constant acceleration of 8 meter per second square. So if a1 is 8 meter, constant means what? Means the acceleration doesn't change, right? So let's say at a particular time t1, it can be any value. The acceleration is 8 meter per second square, and a second time t2, the acceleration is again 8 meter per second square. Then what will be the average? The average will be a1 plus a2 divided by 2, and again this will be 8 plus 8 divided by 2, which is 8 meter per second square, right? So that is why we are getting the average here also as 8 meter per second square. Are you clear? So one thing you have to note out here, that if there is no time involved in the expression for the acceleration, it means that the acceleration is a constant acceleration. Okay, so we have done that, the average and instantaneous acceleration. Yeah, that's it. Thank you.